Hello, my name's Amir. I helped with the displaying a cube with the different colors for checkpoint 1, the texture, simplex noise, and randomization of those, collision, gravity, physics system overall. I also helped a bit with the block removal using the raycasts, and I also helped manage the GitHub repository as well as everyone else.
Yeah. I'm Ethan. I helped with the camera movement and things of those nature, the different cube types and how we added those to our project. I also helped with the ray. Well, we used a raycast for block removal, which was part of our final checkpoint, and kind of decided or kind of came up with the idea to change the texture overall, which we'll show later.
I'm Jonathan, and I helped with chunk creation and with the light source, as well as parts of the collision, gravity, and block destruction.
So if we open up the program, we'll see some of the stuff that we implemented. As you see, when we first open up the world, we see the light. It's halfly illuminated, halfly dimly illuminated. So this is all ambient light, and that is direct light. Um,
Yep.
if we look, the world looks pretty large, but that's because we are generating four chunks by four chunks, so a total of 16 chunks. Each chunk is 32 by 32, and it has a maximum height of 70. Um, we have lakes, we have grass blocks, sand generated over here. If I restart, press escape to close the program and create it again, we will get a unique world. So on this one, we just so happen to not get very much sand, but we did get a fairly large lake. We also have collision detection, so if I walk on the ground right here, and if I press F3, which will put me into third person mode, I'll be able to see my bounding box and see that I am colliding on the ground. If I go to the side of the world and press F, F will make it so that I fly, um, and I will be able to walk onto the side and slide against the side.
Yep.
I can't go into
Um,
water, and
And
pressing
that
F again will
divider,
make it so that I fall.
show the inside of the chunk, the third person mode.
So what I did to save on rendering time is if I stay in third person mode and I look into the world, um, there isn't any blocks being or any quads being generated on the inside of each chunk. It doesn't check with the other chunks to see if the quads should be removed if there's like a chunk on the other side. It's based off of your chunk. So if it's outside of the chunk, all of the quads facing outside of the chunk will be drawn. Any chunks inside of the or any blocks, any quads inside of the chunk that are facing towards a solid block or facing towards water will not be drawn because there's no reason for it to be drawn.
And this is why we get the dividers between chunks.
Mhm.
Also, as you can see regarding the camera movement, uh, Amir Amir has it so that well, right now he's in third person mode. So essentially, what's going on here is based on where the camera originally was, it kind of goes backwards from where the player is and faces the camera at an angle using some trigonometry, some math we did in the code. And whenever he moves his mouse, it kind of points the camera so that it's behind him, looking toward him, pretty much surrounding him. So that's our third person. And then when he goes back in in first person, we can see that the world moves around where he's at. Essentially, what's going on with the camera is that the world is moving around the camera. The camera actually isn't moving at all. The world is moving around the camera, but uh, it gives you the
The
thought
illusion.
that you're actually moving around, but actually what's going on is we're moving the entire chunk or the chunks that we created around the point of the camera. And whenever we move the mouse or the angle of where the object's at will move accordingly using our yaw and our pitch that we have. Um, so that's kind of how we did the camera movement. Another thing that we did using the camera as well is we added the functionality to remove blocks using raycasts. So whenever we press left click, we have the block removal. Basically, what it does is it uses our look through, which we created when we made the camera. And instead of basically, we ran into an issue where um, we were gonna use the raycast that we have with the camera. Basically, we made the raycast based on player space initially. So whenever we would click, it would destroy the bottom corner of the map, which is 000. But we needed to make it so that it was world space, and it would destroy a block in the world rather than, or based on the world rather than based on the player. Initially, it was based on the 000 vector of the player, so we needed to change it so that it matches the world's space. And now we have what we have now, where we destroy blocks based on where we're looking. Oh, actually, yeah, another thing that we added too, which is another functionality, is we could change the entire texture of the map by pressing F4. So before we had the PNG that was on file, we used that texture file, turned it into a 16 by 16 map that we could then um, use as images for each block based on block type. So what we did now is we use a second PNG, converted that into a 16 by 16 block, and then use those for the new texture. However, an issue came up where basically we needed to render it at a consistent time. Like, we weren't able to do it at first, and we weren't really understanding why. But essentially, what we needed to do was put it in our render method,
In the trunk.
so that I'm sorry, in our
Yeah.
chunk render method. So we created a texture ID, and when the world is being rendered, it's constantly checking uh, what our world texture ID is set to, and pressing F4 will change that texture ID whenever we I think it's let go of it.
Yeah. On
So that's something that
release.
we have to.
On
Yeah, on
release.
release. So that was kind of a difficult implementation. It was harder than what we had previously thought. We thought we could just change the file and that'll do it. But what we had previously had set it to was one texture doc, but now we made it so that you could have as many textures as you want. If you wanted to add another texture document that changes it to something else, we could easily do that using this that simple or not the simple change, but that change that we made in the render method.
Um, I don't think on this map we had a lot of sand, but let's see. Does this one have any sand?
Yes. So
Yeah, so we've
the
got a
sand
little bit
is
of sand
just
there.
gummies or something. It looks like
Yes.
gummy or something
Jelly
like that.
beans, maybe?
Jelly beans, possibly.
Um, the way that it differentiates whether if it should place a grass block or a sand block is done by a heat map. I think that I'm botching the term for that one.
I believe it's humidity.
Humidity, yeah,
Yeah.
humidity map.
So we
Uh,
determine what the top block should be based off of a height map, and then we determine where the top block should be based off of a height map.
Using
If we
simplex noise generation.
mhm. uh, So if we go into here, this is generating our height map and our humidity map. It's just going to be based off of our current position. We will also generate sand if our humidity at that position is less than 0.3. So this we just need a 2D simplex noise for the humidity because we're only going to be worrying about the top. Uh, we don't need to worry about depth or anything. It's just going to be between two values. But for the height map, we needed to have that be 3D. If the humidity is below zero point 0.3, that means, or if it's above zero point 0.3, let me check. 0.3. So if the humidity is below zero point 0.3, we set it so that the sand would be placed there instead, and if it was above zero point 0.3, then it would be grass.
Mm-hmm.
And,
Jonathan, you want to talk about the chunk creation, kind of how that
yes.
works?
So for chunk creation, we have our chunks start at zero as x0 and z0. with the y being a constant of sorry, not a constant.
It's just not needed.
Yeah, it's just not needed for that generation because the chunks are placed based on how many we're going to generate, and then from there, when we're filling them in, we use the simplex noise to figure out the y of how high that specific block column is going to go. And similarly, but in the XZ direction for the rest of them.
So we'll do all of that inside of the world class. The world class is, it really could just be created into a singleton class. Looking back at it, that's probably one of the things that I would change is turn the world into a singleton class. But what we do is create a 4x4, which we announced earlier, and it's going to have 4 chunks by 4 chunks. So we need to create 16 chunks. What we'll do is load in the chunks, and then this initialize surrounding block values uh, will be how we determine which quads should be drawn versus which quads shouldn't be drawn. And then we decide to rebuild the mesh every single time we've initialized the surrounding block values inside of the chunk. That's how we load every single chunk. It's inside of a for loop. To be able to differentiate between block space and chunk space, I thought that it was the easiest to look at it like this. So we take I and J for I being the X for the chunks and J being the Z for the chunks. While for blocks we just say X, Z, Y. Um, that just makes it easier whenever I'm looking through the code and I want to see, am I talking about chunks here? Am I talking about blocks? I could very quickly say, okay, well this is definitely about the chunk space because I'm seeing an I or I'm seeing a J.
Yeah. Another thing we had, if we run the program again, we could see water level, and it's set to a basis of 37. So using the simplex noise generation, whenever the level is below 37, we automatically fill that area with water, just to give an idea like of what water. Yeah, and then we change, um, so we could have chocolate water or regular water, um, and that level just stays the same constantly. So that's just sea level represented by sea level. We had a couple blocks that we could have added as well, wood and gravel, but given the specifications that were required, we didn't really need that, so we just stuck with the blocks.
Yeah,
Air, yeah, we added an air block to kind of represent a nothing block. Um,
makes
it
it
kind of helped
easier.
us a little bit. Yeah, it
Mhm.
helped us a little bit um, with the project, and then we just pretty much implemented the grass, dirt, sandstone, and bedrock and water. Yeah,
Mhm.
we had IDs associated, which is what we used for each. So
So one issue that we ran into when doing texture mapping was the top of the grass was always gray. So what we needed to do was change the color to be a hue of green, but only for the top quad of the grass block. So if we look inside of our code over here, when we rebuild the mesh, I turned it into the data that we're putting in. I turned it into one method. It saved significantly on chunk creation time. Um, I'll go into the create cube data method, which we use to fill the vertex position data, the vertex color data, and the vertex texture data. What we do at the very beginning is check which block we're trying to put into the flow buffer. Um, if it's grass, then we're going to change the color pointer to be something else, or the color data to be something else. This is all going to be for the top. This RGB specifies um, the green color. It's
Specifically
kind
the
of a
top face.
Minecraft, yeah. It's kind of a Minecraft green color. Now, if I go down, I can look at our default for the colors. The default for the colors was set to, well, it was actually set up here to be one for everything. That way we don't have to keep inserting the color data. And near the bottom, we append all of that data together, and we'll use that data to bind it to, or to buffer the data into our VBO texture handle, VBO color handle, and VBO vertex handle.
Mm-hmm. Jonathan,
Well,
you want to talk about like
as
the? Oh yeah,
yeah,
sorry.
the as for the light source, actually the light source that's halfway through, we positioned a camera in the middle of the world, and then we have it facing left. So that way, light is shining in one direction, and it's just darkness in the other direction.
Mhm.
And that camera moves in conjunction with the world about where the player is when we're moving.
So we can see that right here. So at the center of the world, we have created the light source, and it's going to only face in this direction, getting brighter as we go along. And then once we get further down this way, it gets a little bit darker and darker until it is as dark as it possibly can be. We can adjust the darkness by adjusting the highest ambient light. So if I make ambient light a little bit smaller, then it'll make the areas which aren't directly illuminated darker.
And
Uh, just to kind of talk about some of the issues or problems or things that were good about our project were I felt first of all I felt like we were all a pretty good team. We kind of all we were pretty consistent on meeting up, and every time that we worked on something, we were generally always in a call. Um, However, due to COVID and everything that's going on right now, it did prove to be difficult at times. Sometimes we had internet outages. Sometimes we just had personal issues going on,
there were
just personal
fires
matters.
raging for a couple weeks there.
Right. So, it times are tough right now. So it kind of bounced onto our project life as well as, our personal lives. So that was a big factor in some of the issues that we had as far as team play goes.
Yeah,
Um,
GitHub though, Amir was excellent at managing the repository on GitHub.
yeah, honestly,
Everything stayed really neat.
The GitHub repository was kind of iffy at times because every time that I would pull from the repository, it would change my files to whoever last changed it. It would change the file for LWJGL's run to the last one that was added. So it was kind
Oh,
of
right. Every time you would pull, you'd need to change the specifications for where the LWJGL stuff
Yeah.
was.
All of that stuff was inside of our NB project folder. So what I did is go into git ignore, and I added the NB project folder so that anytime somebody's pulling, it's going to just ignore everything that's inside of the NB project folder and only bring in the stuff that actually matters for the program. So everything else in the NB project folder is just user specified. It depends on your machine. But all of this source code is still gonna go to you if you pull from the repository.
yeah. So yeah, we fixed that issue, but that was just one of the issues that we had with GitHub, um,
Think-
and NetBeans and everything. But overall, good experience, good people. Yeah.
And did we showcase block removal
Yeah, I believe we did.
in this one? Okay.
Um, if we take a look though, we do have block removal, so we could destroy blocks. It goes fairly far. We can change raycast so that it's smaller or bigger. For debugging reasons, I kept it at a large value. Since this isn't a final product or anything, a lot of the stuff that we're doing, like the gravity is fairly low, so I would obviously adjust that so that it's something a little bit more reasonable. But um, since and the jumping is very high, so that's also something that we would adjust. But that's just small stuff that we would tweak if we were actually planning on releasing it. The next time around, I'm probably gonna work on this again during the summer on my own, just to try and get a sense for OpenGL and C++. I'll probably go about the collision detection a little bit differently, and just start the project off from the very beginning to be able to incorporate collision detection a lot more easily.
And the reason why we can't destroy that chocolate fudge is because it's a liquid, and you can't punch a liquid out of existence in Minecraft.
Hmm.
Yeah. Some things that we probably would want to add are things that you could interact with, like grass, um, or trees, or chests, maybe. But
Like an inventory
we,
system
yeah,
based
even
on
an
which block
inventory
was just
system,
destroyed.
right? But given our time, the time that we had for it, we feel that this was good enough and actually went above. We actually added four new additions in our final checkpoint. So we added the gravity, we added collision, we added the fly mode, and then we added, well, that's
Well, there was
in that
the
in sweat.
water and
And
block
then we added
destruction,
the texture change and the block destruction. So
and
actually,
yeah,
we added a handful of stuff, but
quite a few
yeah,
things.
there's definitely a lot more that could be done if we wanted to make it like Minecraft.